He has 15 years experience in design engineering, mainly focused on efficient production of components for high-end applications. He took the challenge to explore additive manufacturing for serial production in depth. Challenging current limitations is his mission. Ladies and gentlemen, he is the business unit manager for BMT Aerospace, Ewald Goossens. Round of applause, please.
Thank you for the introduction. Good morning. I will now introduce BMT Additive.
You need to be a little bit more sensitive to the microphone.
Okay. I will introduce BMT Additive to you. First of all, I want to talk about the reason of the existence of BMT Additive. I will also say what materials we are interested in. This is in titanium and in high-strength stainless steel. BMT Group is a big company, and in general, we identify as metal farmers. We produce high-end metal components in a very efficient way, or we try to. BMT Aerospace is part of it, and we are making components like the ones you now see on the screen. We call it torque transmitting components like gears, levers, shafts, but also gearboxes and gear assemblies. If you have a look to the bottom left picture, you see that there is a very intricate part of the gearbox, which in future probably will be rather manufactured by AM than by casting or forging. So BMT Additive tries to anticipate to the future production needs that our customers will come. Currently, BMT Aerospace is very vertically integrated. In order to be very efficient, we have all processes in-house, except of the forging or casting process. We do a lot of machining, heat treatments, final grinding process to get into the micron level, then all kind of inspection methods, surface treatments, to the corrosion protection layers and hardening layers, and the certification. But the first two, they could be replaced by additive manufactured components. This could look like this. So here we have a component that is designed for additive manufacturing. Currently our key strength is designed for manufacturing, and customers come to us especially for that. 90% of the cost of a design is determined during the design itself. So if we want to be good in the additive side, we also have to know how to design for additive manufacturing. We can make optimal usage of the material and increase the performance of the parts. You also have the advantage that you have a lead time reduction. You see that we will be even more vertically integrated. We'll have everything in-house and no forging dies needed, so the lead time can reduce. BMT Additive is the answer to those needs, and we made 3 important choices to start the company. One of it was choosing for EBM technology for the material titanium 6-4, which according to us is very suited for our needs. If you think of the lever or the gear housing component, it's ideal for our component sizes. It's quite accurate, you have 0 internal stresses, and it has a quite fast printing if it comes to bulky zones in the part. If you compare that with laser, it's a lot faster, and it means that it can be competitive with the investment costing of titanium components. Investment costing of titanium is also not very easy. So, second choice is the focus on the high-strength stainless steel. We see currently a lot of our parts are made out of 300M material. This is not corrosion resistant. and is currently being replaced by materials like C465, which is a high-strength stainless steel and doesn't require corrosion protective layers, so it can be made cheaper. And we're also looking for possibilities in rolling contact because we are a gear manufacturer in the first place. We see that in additive manufacturing it's possible to develop materials, new powders, that can be made in powder, but not in conventional ways. But if you have the power, you can build powder, you can build bigger parts by printing it. The last thing that's very important, we gathered some people that have quite some knowledge about all the internal processes that we have today, like materials, the heat treatments, surface treatments, because we want to master the process if we want to do additive manufacture for our customer. We do a lot of research. We have some research research tracks on powder management. So we first start on maximum 13 times recycling of the powder, but now we are already at infinite recycling, at least for industrial applications. We also use our own parameters because the standard team that we get from Arcam is kind of a one-size-fits-all solution. And by doing research, and you see a picture of a matrix that we pulled here. So we want to serve dedicated purposes. If the customer is interested in density or in speed, we have special parameter sets for that. We also, of course, we need also strength as an input for our design for manufacturing. So we have the yield strength and the ultimate strength for several kind of post-treatments of this material. Also elongation, you can see on the top left graph. We do fatigue testing together with some consortium. So on the right graph, you see an example of a notch factor of 2.3. Very important if you want to replace steels with titanium is also the hardening of the surface. We can harden it up to 75 HRC. The sintered powder removal is also an obstacle. We had in the beginning quite some trouble because by blasting you cannot remove the powder with it from an EBM process on the inside. So we developed methods to clean channels, and we now can clean channels up to 1.3 millimeter diameter, which for laser is easy, but for the EBM technology it's not. So then we can create these kind of matrices. In order to keep the printer running, we speed up our learning curve by producing for industrial components. So we have some business in marine, but also in all kind of nozzles that we produce. Here you see one of our examples. It's a nozzle that is optimized using flow calculations, CFD. By introducing those channels, we can increase the productivity, and this becomes a business case. When the productivity increases, it multiplies the value of your part. We also want to take it a step further. We have quite some knowledge in the design of die quenching tools. So a lot of our parts are hardened in a die, and the cooling rate is calculated using multiphysics calculations. And this is also very interesting for developing new parts in additive manufacturing. So also we produce parts for glass mold business, and also there we are producing or we are planning to produce parts in Inconel and cobalt chrome, optimized using multi-physics calculations. The last thing I want to talk about is our cooperation with Carpenter about a high-strength stainless steel. Carpenter is a manufacturing of conventional materials, but also from powders. And together with us, they developed the C465 powder, and we are doing an application for them, which is fairly easy to start with. It's not a a very intricate gear design, but we need a corrosion-resistant alternative for our slat actuation, so the front edge of the wing. But nevertheless, we are going to take that to a flexible wing test by the end of next year, either with titanium or with the C465 material, or both. The goal, as we are doing a lot of our business, 600 million of our business is in gears, the goal is to support our customers with more power in a gearbox for the same size. We can use the advantages of additive manufacturing, like lubrication or sensing channels, and also by tweaking the stiffness, we can impact on noise and vibration inside the gearbox. So we're working on this in the background. Thank you very much.